Hey everybody, this is Alistair of Retronic Mods. You may know me as Abrooks on Discord or Instagram. And this is my PyStorm tester, ZZ9 Plural Z Alpha. This is going to be a quick overview video of what it's all about and how to use it. So let's get started. So the main purpose of the ZZ9 board is to allow you to see what's going on with your PyStorm after you've built it. If you're getting errors on load or whatever, this will help show you where the errors are coming from. So the main thing we have on the ZZ9 is are banks of LEDs to show what the data lines on the PyStorm are doing when you run either BUP test or the ZZ9 specific tests that are written in the GitHub repository for it. So all of the data lines that are not data bus or address bus are on this side of the board. So we have anything that's an IO is in this area here, and over here we have items which are just outputs and a couple of spares for you to connect up anything. As I said, this bank here are IOs rather than just outputs, and this array of pads here are to allow you to connect the IOs, either force them high by connecting them to VCC here, or force them low by connecting them to ground, which is on this line here. There's an oscillator here which generates the clock signal, and that's required for the PyStorm to actually run outside of the Amiga. So with the clock signal that's coming from the infinite improbability drive, the PyStorm will tick at 8 MHz, allowing the bus transactions to take place, which means we can feed it commands from a Pi to make it think that it's connected to an Amiga. There's a USB socket here for powering the whole thing with 5 volts. It can either be powered through this connector here, or with the main USB socket on the Pi 3. It can be powered by either the Pi 3 socket, or if you want to test the power handling capability of the power pins on the PyStorm, then using this will highlight any power deficiencies when you connect it up, because you'll get the lightning bolt icon in the corner of the screen. Now if we take a closer look at the other side, this is going to be the most useful side to diagnose issues with, because we can actually do something with programs on the Pi to force things to happen. So we have the address bus here with A1 to A23, and the address strobe which is marked as AS on here, and the data bus, which is D0 least significant bit at this end to D15 most significant bit at this end. And again, with data bits, they're considered IOs, so we can force them to be high or low by connecting this middle row of headers to either ground or VCC to make them high or low. These LEDs go through current limiting resistors, and these are 1K in size, so you can put them to VCC and without worrying about blowing up the LEDs. So you can use just a piece of wire, or you can use a resistor to connect the 2 pins. In this case, just putting the resistor into the hole from one side to the other will do the trick. So to set up the ZZ9 tester, it's just like setting up the PyStorm in a real Amiga, where you put the PyStorm in pin 1 notch to pin 1 notch, which is marked on the board here, and there's pin 1 notch on the PyStorm. So if we just literally insert, and then once that's in, we want to make sure that the Vogon Poetry is covered up by the Raspberry Pi when you insert the Raspberry Pi 3. In this case it's a 3A, which is the or 3A plus, which is recommended. So when I power on the PiStorm with it all assembled, we'll see the basic state of the lights that come on. And you should be able to see that by default the lights that are always on are the 7 blue lights here, and IPL 2 and 0 over here, and address strobe. These are always on through the bus transactions which are being handled by the PiStorm even when no bus transactions are happening. So I've turned the ZZ9 around so that we can see the bit that we're most interested in, which is the address bus and the data bus. There's the address bus and there's the data bus. And if we load up, let's say bup test, so let's do sudo /bup test, and then run that, and then we'll see the address bus going crazy, and we'll see the data bus lighting a few lights, but really we're not seeing very much happening on the data bus because it's mostly reading from the data bus at this point. So we see a little bit of action with the lights being lit up, where the last thing that was written to the data bus has been latched onto the flip-flops, and they've held. So we can see that in the results on the from bup test, where it says that it's read 25 25 25. That's the hex representation of that pattern there. If we just run it again, you'll see it. All the lights on the data bus flash briefly, which is the whole contents of bup test being written out to the address bus as it writes it. So that was it. That was all of the writes, and now it's doing reads. It's doing various sequential reads, and there it just wrote a load of data again and again, but now it's reading it back, and that's it done. So from the point of view of ZZ9, this isn't a very useful test. We can see when address bus pins aren't being used, and we can see when data bus pins aren't being used, but only for a very short period of time. So if we run ZZ9 full test, sudo /ZZ9 full test, and what it will now do is it writes to one address at a time, and then now it's writing to one data bit at a time, and we can see it going up one by one, and then coming back down again. All the while the address bus pins are going wild because it's writing to the whole address range in order to persist it long enough so that we can actually see it. Now for this step, it's actually writing out to the address bus and reading it back again. This only works on certain types of flip-flop. If they're the non-A variants of the flip-flops, then this will work. If they're standard 373s or 374s, you won't even see this light up because it only lights up for a fraction of a second when it does the initial data write, and you can't see that one operation. So now, if we want to test the read functionality, then we'll do the read loop. So because this is a non-A variant set of flip-flops, the read loop that we just saw worked, and it reported back that there was no errors. Well, actually it reported back there was one error, but that's because of a mistake in the code. But generally it'll report back with no errors. So if I now do sudo /ZZ9 read loop and run that, and what it will now do is it will loop just reading the data bus, and because there's nothing being written to the data bus, you can't see anything. However, if we pull one of the data bus lines high by doing that, and you'll see it persists now, and it also persists as a 1 on the output of the read loop. And if we do another one. And now we have two ones. 1, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. And we do another one. And we now have three ones. And if we want to clear those, we can do. And as you can see, the ones clear back down to zeros on the read test. And if you want to set all of them, and there you can see they're all ones. And so with that, we can then clear them back down again. So that's about all that can be done with the ZZ9 test with the pieces of code that are in the GitHub at the moment. The other data lines can be read and modified by with a oscilloscope, or by connecting them to another microcontroller like an Arduino or something, in order to actually see in real time what's happening with those pins. But at the moment, the lights will be strobing so fast that you can't see the individual changes with the naked eye. Those ports are really there for hooking up to an external device, like as I said, an oscilloscope, or with a microcontroller like an Arduino. And it will be for people with more intelligence than me to be able to actually do something with those and rewrite the code to be able to manipulate those. So all of the code and schematics and design for the ZZ9 can be found on my GitHub, which is github.com/abruksh/PyStormTester. Link will be in the description, and it's open source, so do what you want with it. Hopefully you'll find this useful. So thank you very much for watching, and good luck. These lights here